All right, good afternoon. I am Anto Budiarjo. Welcome to Monday Live. This is something that we do every Monday afternoon to try and figure out the future for smarter buildings. Really good to see you. In case you're wondering who we are our LinkedIn profiles are listed on mondaylive.org, so you can head over there to find out about us. A point to note that I always bring up is the views expressed here are personal, not of any company or organization, so keep that in mind. And please do use the Zoom chat for questions and comments and other information that you want to share with the group. We encourage that sort of interaction during this hour. In case you want anything that is presented on this slide deck, it is also available on mondaylive.org. So mondaylive.org is the place to be, as it were. This being November, and this is the last week of November for us. We've been talking about systems of systems, more accurately. So we'll continue this one last time, and I'll explain our tack this week. Specifically, what we want to talk about is we want to talk about the brittleness and the loosely coupledness of systems aspect, and how system of systems sort of plays into that. And we'll explain a lot of that as we move along. So looking forward to that. But before we go there, hand it over to Mr. Ken Sinclair.
Thanks, Anto. Lots going on at Automated Buildings. I was just reminded that when I started Automated Buildings, someone described the internet as a library with all the books on the floor. And what was our task was to pick these books up and put them into some kind of organized thought pattern that they would be useful to the world. So 25 years after running Automated Buildings, I find all my books are on the floor, and they're not very easy to find. And we've been trying to straighten that out, and actually having a lot of fun finding a lot of gems, finding a lot of the words and a lot of the thought that's going on in Monday Live has really been talked about before. We've just not really been as active as we have been with Monday Live. So we're still, our 25-year history is there. There's lots of good links there. I'm going to share the slide in the chat when I'm done here. We're working hard on our AHR online program. We're adding speakers daily, confirming them. Really, we've been chatting with them, but it's just making sure they can come at that date. And we're working on generating the flyouts that will have extra information about each one of these sessions. So that should be good. I wanted to do a shout out to Project Haystack. They've got their Connections magazine online. It's a great issue. Lots of really neat articles. Lots of people participating. Make sure you click on that link and go and take a look at what they're doing. The other one that's kind of surprises me is we have this Automated Buildings online magazine forum. We've run it forever, and it keeps sneaking up. We get more and more members joining every day. We're up to 4,890 members now, and it's kind of taken on a life of its own. It's a free place that you can just go and post stuff if you're a member. I was surprised by some of the interesting stuff that appears on there. Sometimes I have to take the odd nude lady off, but not that often, actually. So it's pretty good. Anyway, take a look at that. It's a good way to when you just want to post something. Maybe you've got a meeting or something that you'd like people to go to. It's basically the bulletin board in the library, in the Automated Buildings library. Another one that came to my attention is Jane and I originally started SES in 1975, and we turned it over to the kids I think about 10 or 15 years ago. They basically are now reminding us that we need to realign our values. There's so much change going on in the industry, and people are losing jobs. Real estate is moving. So many dynamics, and we really need to align our values to help to use our prosperity that we all have in this industry to try and help, try and create, try and make community better. And there's a program out there. So if you click on that link, you'll see what they're doing. And I'm very impressed with what they're doing, and I do applaud social purpose. I think we have to think about what that might mean and spend a little bit more time. The other thing that we've done is we've come up with a new way of presenting our past issues. We've come up with a table, and I think it's actually quite useful. You can see below what it looks like. And so every issue is, if you click on the month, you actually go to the issue, and the theme is outlined, and it takes you directly to the editorial words. And then we have a brief description of it, so you can quickly look through all of the time that we used Pinterest as our menu system, and you can kind of see in a spreadsheet type of thing all of the articles, and I think it's good. And so I just picked this one here that we were talking about digital inclusion, and I think a little bit that's what we're still skirting around, and we're also skirting around the user experience. So, and those were from several years ago, so it's interesting. There's also another Pinterest presentation that actually shows the boards, and if you click on that, you can kind of see that. So again, it's trying to pick up the books that are on the floor and put them into some kind of a manner that you can quickly look through them and see if there's any of them that you want to read. There's an awful lot of resource that most of the people around the screen here have donated their time and articles. So it's good stuff. And actually, it's interesting to read these articles from several years ago. They read pretty true today. It's amazing how accurate they are. Back to you, Anto.
Thank you, Ken. Talking about reading, I came across this piece, so I thought I'd share here, because we've been talking a lot about clouds and mentioned Kubernetes many times in the past few weeks. And I know it's a concept that's can actually be complicated, very complicated. So I saw this article that I think you all may enjoy, thinking about what Kubernetes does by comparing it to what chefs do in restaurants, basically. So just kind of a bit of a fun read, and it actually explains what Kubernetes is all about. So that's my contribution for this week. Rick, anything new from you?
I'm gonna have to look at that, because one of our themes is kind of, we're shorthanded, we're saying Kubernetes for buildings is what the coalition is advocating and trying to demonstrate. And so we've got the office hours, which is our monthly attempt to invite people to come learn how they can, as individuals or as companies, participate in what Coalition for Smart Buildings is doing. And again, Kubernetes for buildings has been proposed as a shorthand for what some of the stuff is that we're building and getting ready to demonstrate. And then at AHR, AHR is the next slide. But do you want to talk about Smarter Summit?
You start and I'll finish, and we'll move on.
So the Smarter Summit will again be at the Sunday before AHR, and we will have registration and more details coming soon. But just get it on your calendar. And again, the things we're doing with the office hours and the work of the coalition and the different committees, volunteers, will sort of all come together one way or another at the Smarter Summit and at AHR. And so reach out to us if you have questions about how you could be involved, and look forward to talking with more people.
Yeah, I think this summit coming up in, it's now 2 months, maybe less than 2 months. it's going to be quite good, because it sort of brings all of these issues for this group to discuss. So really looking forward to that. And it's also we don't have a website yet for it, but if you go to the AHR Expo website, it's actually listed there as one of the free sessions, so you can bookmark it there, so at least you keep track of it there. So please do
I'm
that.
very pleased if you, Anto, as a contributing editor, or C4SB as contributing editors would basically put something on our website so we can circulate it out over our social media network.
Okay, we'll get that done. Our links as normal. And before we jump back into System of Systems, any more thoughts or news anybody want to bring up? Hearing none, let us dive into System of Systems and brittle versus loosely coupled systems. So what's this all about? So this is really how you design or how you think about complex systems. And systems can be brittle, meaning that they break easily, or they can be loosely coupled, meaning they're very flexible. In relatively small systems, this doesn't really matter very much, but as systems get larger and larger and more complex, this becomes a thing of its own. And why does it become a thing? I'm going to show this table, which is somewhat similar to a table I showed a couple of weeks back about the comparison between engineered systems and system of systems. In brittle coupling, you have these sort of attributes. The interdependency is very high. So in other words, a component of that sort of overall system is dependent on other things to work exactly as they expect. That's sort of one aspect of it. That causes the resiliency of the system to become low, which makes changes difficult, because when you change something, it changes a lot of other things, and therefore, you don't really know what you're changing, and that's part of the sort of the brittleness of it, which makes it highly vulnerable to failures, because things can fail that way, and that can cascade to other things that break. So that's kind of the sort of the scenario of really brittle systems. In terms of how they design, they typically are monolithic, large. And the way things get coordinated across this sort of complex system is very complex, because you don't really know where everything is, and everything is in a very specific place that has to be there for whatever reason. And because of all of this, the risk of failure is really high. When you compare that with loosely coupling, the interdependence is low, which makes the resilience high. This makes the change, the adaptation and change to be very easy, which lessens the vulnerabilities. Therefore, the cascading effect doesn't really happen. The design, on the other hand, is not monolithic, it's modular. We've been talking about that, obviously, for many months now. And the coordination is very simple, and therefore the risk is very simple, right? So this is very complex. And somebody told me some time ago, if you want to explain something, do it to a fifth grader. So this is kind of the way I'm thinking about that. This is kind of on the left, obviously, we see a house of cards, which is sort of my analogy of a brittle system. You touch something and the whole thing breaks, right? You can't change anything. You can't sort of decide that three of hearts, that three of hearts should actually be something else, and then just pull it out and put it in. You maybe could if you're lucky, but the chances are it's all going to break. And you can't change it as well. It's really very difficult to think about that. Whereas on the right, we have a Connex base house. And you can see without sort of much thinking that that door, if you decide that door needs to be moved to the side or to be changed, then it's very easy to just snap it out and snap it in. And when you do that, when you're actually making those changes, it doesn't really affect anything else of the house. The house doesn't fall down just because you take out one piece, whereas on the left, it does. So this is kind of the simplistic way of doing it. Our way of doing it in Monday Live is we have this thing called the smarter stack. So what does this comparison look like? So a brittle control system is basically a box like that, and we've talked about this many times. It's fixed in terms of all of its functionality, all the way from the bottom to the top. Whereas a loosely coupled system is more like this, and this is just a random smarter stack slide that I found from my archives, just to sort of as a comparison. So I kind of just wanted to put that out there as a sort of a framing in terms of what this topic is all about: the brittleness and the loosely coupledness of systems. And I'll stop here and open it up to the dialogue, and we can continue. Any thoughts or critiques or? Very quiet today.
I like your analogy. That's great. The house of cards and the Tinker Toy sets is a great way of looking at this. Yeah, it's just, and the proprietary tends to be that smart but inflexible. I mean, that's the kind of systems we're building. And it looks like, and it is a silo. So I think that's implied in there too, is you can imagine the house of cards as a silo and the other one is open. Yeah, great analogy. Well done.
Yeah, I'd echo that too, right? Is that the flexibility, one of the things that we recognize, especially in the smart spaces, and COVID kind of brought this to the front, right? How things have changed dramatically, and even post-COVID, what's happening today, you got to stay highly flexible in our space at the moment. I know we talk about putting systems in that last 30 years, but some of the applications and things that we're talking about and related to as far as smart's concerned, flexibility is one of those ones. There's just still a huge amount of uncertainty about where things are going to go and what's going to happen moving forward. So it's interesting. I love the slides, like Ken said, because I think this is one of the things that we've started to take on in what we're doing in that whole concept of flexibility and smart.
So let me ask the question of all of us around where this is the inflexibility mostly showing up when you're trying to get dissimilar systems to coexist or cooperate, if you will, versus flexibility within a given silo of control or automation. So if I go back to the 80s, there was this pre-configured software versus programmable. And programmable, for the most part, won the day because of the need to be flexible, because you didn't know what you were going to come across in terms of the mechanical systems, and you needed software that could adapt to whatever was there, right? So, and then further, from an input-output standpoint, things like universal inputs got developed, again, because you didn't know what your mix of digital and analog inputs would be like, and how many different types of temperature sensors, RTDs versus thermistors could you handle? And I think the industry has done a pretty good job of adopting those concepts within a silo, so that the I/O can be easily adapted to whatever the situation is, and the software can be adapted to whatever the control needs are. Okay, but where I think our conversation has led us when we talk about the smarter building is if the conversation is how do I connect and obtain that information from these systems, that's point number one. I want to just get the information out and look at it and do something with it, and or share it with other systems. So that's one issue. And then there's the issue of systems, of the different types of systems, whether they be building automation or lighting control, physical security and so on. How easy is it for us to have those systems interoperate? And so that, you know, when my name it system goes end of life and I need to replace it, is it going to be equally possible to put in the next generation and have it talk to the remaining systems without doing lots of custom development to accomplish that? So I just want to steer the ship here a little bit in terms of where our focus is on flexibility and smarter.
Yeah, I think that's a good lead in, Steve. In fact, I really loved the analogy of the control systems back in the day, right? And I was right there with you with that. You know, the systems that had either the fill in the blank type or easy but fill in the blank type questionnaire things, you know, got things done but had zero flexibility if you had to do some version or change, versus the guys who are kind of more free form programming language types, which did win out in the end. And we see that in some of the other applications like fault detection diagnostic softwares and some analytics pieces through, you know, do you go with the easy fill in the blanks, or do you keep it, you know, highly flexible with script, but it's a lot more complex approach. And so I'm, from my perspective, to answer your question, I'm coming more from the what do I do with the data once I have it, right? I'm kind of moving past the getting data is hard phase. I think that's changed a lot in the last few years. It's still not simple, but simple doesn't, in my mind, simple doesn't equate to flexible, right? It can be complex on how I get it, but I can still, once I have it, the flexibility of what I'm using it for is paramount to me, more so than the easiness of getting it. Easy, if I get it, it was easy, but then I just gave it to an application that was inflexible, then I haven't really gained much. So long answer to your question, mine is more focused on what do I do with the data once I have it.
Okay.
I want to jump in before we take this picture down, because I think this picture is cardinal. There's a lot of great stuff going on. The other thing we've got going is we're adding stuff to the equation that we hadn't really anticipated. Interactive grid, which we talked about last week. Can you imagine adding interactive grid to the house of cards? It's just not going to work. And also we're talking about user interfaces, and we're talking about things like the telco industry attaching to our industry to turn us into a service. All of those things cannot happen in a house of cards. But as you see in the other one, there's all these connectors just holding there in space that we can actually connect to and become part of. So the trouble is the house is not finished yet and never will be finished. We need to be able to grab it at any point and rebuild it out. So again, a great analogy.
I would say that the way I tend to think about this is from the perspective of the architecture of the systems. And I'm going to try and bring up another slide that we've used. There you go. This is a slide that I've used in past weeks. This is a typical slide of a BAS system. We've seen it over and over again. This is just a random one I got in on Google. The point here is that this is fixed. This architecture is fixed, right, by its functionality. This programmable logic controller has to be there. It cannot be here. And this you can't sort of move things around in that way. That architecture is fixed. And therefore, if you want to do something, you have to fit into that architecture, or you don't do it at all. You can't be flexible about it. To me, that's the way to think about it. Whereas a more cloud native architecture doesn't have these sort of constraints that are very, very inflexible. Because you can literally be a lot more free in terms of where data is and what data you use in the sort of cloud native way of thinking.
So getting off the word cloud native for a second, are you just arguing that a flat architecture where everything is IP is the answer to your simple architecture?
Yeah, and IP is the only the main framework that we have right now. Yes.
Okay, yeah, because that would be the core difference, is that everything that's on the so-called secondary bus, on the secondary bus or buses, those devices would move up to IP, and everything would just be a straight line going left to right.
But then I think that's only part of the story. But by putting it all
Okay.
on IP is one thing, because then on the network level, everything's all on the same place. But then you have to think about, how do you control access to data? How do you, do security and everything else? That also has to be flexible. That cannot be rigid as well. So there are
Yeah,
multiple
agreed.
layers, multiple layers to this. You can't just sort of reduce it down to IP solves everything.
Well, but I agree, but it's the table stakes, if you will, to doing the rest of it. So there's no point, otherwise you have to have some sort of gateway device in all cases if you're going to have any kind of secondary bus, right? So so the only way to get to translate that secondary bus data into IP packets, you need some sort of either PLC or gateway to get up to IP. And now you've got the new challenge of different protocols, and different ways of communicating information, or the need to communicate information across the different devices and users. And how do you do that in a simple but flexible way?
But I think the point is, I think you were sort of doing this. If you're trying to do that in this architecture, you have to think about, what if I put a gateway between my new device and this layer, right?
Right.
So that's great. That can work, right? But that in itself, that adds to the brittleness. You've just added another piece that can break. If that breaks, then it breaks. Whereas in a system that is well designed, the sort of cloud centric, well designed, you should really be able to design it. I mean, Kubernetes is brilliant, because the way it works is that when an application dies or crashes or whatever, it is smart enough to say, a couple of minutes later, start another one. And it just starts another one, and life goes on, the world goes on.
Right.
That's kind of, to me, that's sort of that is the contrast. You can't do that in this kind of environment.
The only exception I would take to what you're saying is the installed base has huge numbers of those secondary bus devices in it. And I guess our answer to that is the IBB, so that you can bring that data into the IBB, and now it's treated as a cloud native subsystem, effectively. Is that because it's one thing to design the next generation architecture to be all IP based. It's another thing to deal with the million plus buildings out there that have systems in them.
Yeah, and I think Jim uses this word a lot. I'm going to bring it up here. The IBB becomes an impedance matching mechanism between fragility that exists southbound of it, right? That's not going to change, because, as you said, those devices are not just going to be ripped out. Between that and the flexibility of cloud native, that's sort of mostly northbound of the IBB. Does that make sense, Jim?
It does. It does. And, as I've been listening to the conversation, I think I have to take this back to Anno's point. I see this whole evolution from the brittle to the flexible being a journey. And we started on that journey a long time ago, before a lot of these technologies or systems were available. And now we have lots of open standards, BACnet, Haystack, IP. So we're getting more and more flexibility. But I think the thing that is really important is, once again, this is a legacy industry. The 5.5 million commercial buildings that are out there have existing technology in them. And while we do need to plan for the 1% new construction and the 10% retrofits every year, we have to be very mindful of that. And that's why devices like the IBB can act as an excellent impedance matcher between the past, present, and future.
Yeah, I think some comments there in the chat with like Rob and Sheldon. Rob's bringing up the, just a transition from one to the other there's a lot of factors that's beyond technology, right? There's a lot of people, IT, infrastructure folks, SIs, and Sheldon brings it up as well, with the, with the folks that's involved.
Yeah.
So
yeah, it's an
a
excellent
complex
point, Anno. Excellent point. And one of the things, in order to get these flexible systems, we need our consulting community to understand this. And what we need is maybe some rules of the road for specification, so that people can at least be skating to where the puck is going to be.
Right.
Yeah. Ron's point, right? You need knowing where you want to go is a big part of is a big step in what you're trying to do here, right? I mean, why are you trying to do the thing? And I think that's an area that I do find a lot of clients have challenges with. They kind of know a lot of the buzz, and they've been around in the space, and they know the things that they sort of kind of want to do, but to kind of join the dots for them, or connect, we call it connecting the dots for them, is the thing that they're really looking for, right? How do you they look at all the new stuff coming out, they look at all the great capabilities, and then they look at what they've got, and then how do you help them sort of connect the two dots together that actually makes sense and value to them in the first place.
Yeah, any other thoughts? Tracy, David?
I was going to ask again, coming around to what Steve was talking about. So if we were designing a system from scratch, brand new, are we advocating a flat architecture in order to create a cloud native, fully interoperable, Kubernetes friendly kind of a architecture?
If I were to answer that, I'd say that that's a starting point. I don't think just by being flat and being IP actually in itself gets us there. That just puts it all on the same network, right? So technically you can access any other things on the same network. That's what the flat network does, right? But you have the layers above that in terms of orchestration of, because the internet is flat, right? There are 4 billion people or 2 billion people, whatever it is in the world, right, that is on the internet or devices, right? And technically, from my computer, I can ping any other IP address anywhere in the world. But do I ever need to ping any more than a few that I care about? No. So the vastness of the IP space is actually not useful. What's useful is what's useful to you, which is the IP within the building and the systems and what they're doing, right? So just by
using that as an example, I mean, when you dig into it, the internet is not really a flat architecture from a hardware standpoint, right? There's series of routers and gateways and servers and so forth. So I think the concept here that we're trying to get across more than anything is the ability for data to flow through whatever hardware architecture is out there, and making that orchestrated automatically to a point where if this path is busy or down, it goes this path or it takes another path. I mean, I highly doubt that if I send an email from here in Phoenix to Jim in New England, that it takes the same path over and over and over again, on any given week or month of the year. So that's the concept I want to make sure that we're kind of getting out there. It's less about the architecture and how many different protocols or buses or layers or anything that we have. It's more about the orchestrated flow of data to be open, have multiple pathways to get to where it needs to be, like the picture on the right here, right?
And the point that Ron has just chimed in is, asking the definition of flat. That's why I sort of have problems with that word. When you say flat is a very definitive word, right? And it's not like that at all. As you said, the internet itself is not flat. The addressing, you can argue the addressing scheme is flat, right? Okay.
It's I just had a thought that it escaped me reading Ron's thing. So it is coordinated and managed, as he points out, and it's in it. What I was going to say, it is really not like IP. It doesn't have to be IP direct connected point to point to a switch. That's not what we're advocating. We're not advocating everything on a flat backnet bus. That's not it either, right? It's more about the data flow, orchestration, management of who gets what data, who has access to what points, that kind of implementation. That's the architecture. It's less about hardware and more about the logical architecture of how data flows.
Right.
And I think that when
Trying
we
to simplify it for us dumb guys. So
yeah, although you cannot, by saying that, I totally agree with everything you said, Tracy. But by saying that, it doesn't mean that the network doesn't matter. You obviously need to have things like IP because it's great, but it's not just about that. It's about things. But
yeah, all the pieces of hardware have to be enabled to perform what we're talking about, right? Routing, management of any layers below it or adjacent to it. So it has to be connected in such a way with the right kind of software running to know what's below, what's adjacent, what's above. That part of it's important from a hardware standpoint.
So
I'd
as
like
a way to
fold
look,
in, sorry.
I was
ahead,
going to
David.
say, is a way to look at this then is not flat, but a shift to horizontal from vertical. Because again, look at all the architectures, even the one you just showed earlier, and Anto, that to me that says vertical. And again, we go back in history, and all of them are everything we've ever shown in the industry has been vertical. Okay, with IP and the right architecture, all the things that you guys have been talking about, is it one that is horizontal? And then to your point, mapping out who gets what data, where, when, whatever, and so forth and so on. That's what I would argue.
I'd like to layer in the concept of cybersecurity for a minute. So we've talked about certainly at the base level, the fundamental information, the protocols, the data definitions, the ontologies, all these things, metadata, are absolutely critical to turning that data into some kind of value. But we're entering a world with cybersecurity where we're going to restrict access to who can read that. So we've talked about these flat open architectures. That's all well and good, but now we need to have some kind of Active Directory like structure, which allows us to know what we're able to read or write. So that the elevator can't turn on and off the lights necessarily, or it can if you program it to. So these concepts of authentication and authorization are critical. And another layer, which is going to have to be, part of these systems, which authorizes certain systems to talk to other systems to get that data.
Yeah. So to that point, Jim, user authentication within the world of IT is well established with like Active Directory as an example. Device authentication, however, seems to be not in the same world, where it's been engineered to be very specific to the vendor and designer of the software. Maybe I'm unaware of a device authentication method that's being used successfully in the IT world. What are your thoughts on that?
Well, out for public review right now, should you mention it, is BACNet's answer to that. So
Okay.
there is a BACnet public review going on. Actually, it just closed for authorization and how that's going to work. And I think it'll be broadly adopted for the reasons you just said, Steve, which is, it's completely proprietary now in people's systems. And to get any degree of interoperability on cybersecurity, it needs to be standardized. So this is the second public review. So I would expect more modification, but within a year or so, I would say as an industry, we'll have a standard for specifically solving that problem of
Yep.
how do we handle authorization for devices,
For devices.
as
Yeah.
well as users.
Right.
Yeah, and so just to pile on Jim's point about and to bring in my favorite hobby horse of the IoT guys, just for one more time, the fascinating thing I see is, you look at the IoT guys and how poor they are in any concept of even the concept of device or authentication authority. I mean, they don't build anything at the device level. They kind of rely on the cloud level to do all their cyber. And this was, without going into details, this was kind of came to us just recently, a little while ago. Just recently, a few weeks ago, where we were dealing with an IoT company. It was just their concept of who could and couldn't have access to certain parts of the data was so poorly architected that it was. We talk about, like Jim says, what BACnet SC is doing, and down at that particular level, and the maturity and the sophistication that we built into that sort of architecture. And then you go to the IoT infrastructure, and it goes like, well, we do some cybersecurity at the cloud level, but nothing down at the device level, and it just blows me away when they have the opportunity to do something significant in that space.
It is a hard problem. And, people in this industry have been grappling with it. And that's why I think that, while everyone in IT will scream that they're light years ahead of what we do, I would say they are not light years ahead in what we actually do. We are actually doing it as an industry and have been for the last 10 years.
Right.
With respect to our domain. I'm sure they're very sophisticated, more sophisticated than we are in their domain.
Listening to this sort of,
Oh, sorry.
let me
if
just
I
make
could-
my point, and then I'll hand it over to you, David. It's worth noting how IoT is doing in our homes, right? Because there are some lessons there in terms of how authentication and authorization happens there, right? It's not fixed yet because it's still a bit of a mess between different systems, and people are doing things like Matter. But it's actually just worth watching what's going on in that space, because there are some models, right? When you buy a new Ring doorbell, there is a process by which you authenticate that doorbell to be in your house, right? So the flows and the processes exist, but not necessarily implemented in our industry, and that's what Jim was saying. But I'm good, David.
Thank you. To Ron's point, as well as what a number of other folks have mentioned, especially Jim with cybersecurity, the foundation to things, from my perspective, is a properly provisioned IP network. And when you have an IT team at an organization that knows how to securely provision an IP network, it really locks down which systems are on which specific subnet, exactly what data can be transmitted from one subnet to another, including protocol and port numbers and things like that. So IP networks can be very well configured for not just cybersecurity, but for flexible data exchange, depending on the type of network it is and the organization's requirements. And from my experience, I've seen, all of the building systems or OT systems share the same subnet. I've done projects where lighting has its own, AV has its own, HVAC and BMS have their own, energy management has their own. And then the lifts have their own, and access control and video surveillance have their own. And when you start to manage your network in this manner, it makes it very easy to allow access to certain subnets for certain contractors so they can have remote secure access and not screw anything else up. But it also allows organizations to shut things down and easily control things if something goes awry. So if there's a switch, a small switch in a mechanical space and somebody jacks in a laptop that's not supposed to be on the network, they can shut down that individual port or that switch or whatever they need to. And the network can be properly provisioned to shut that down automatically if it detects a device that's not supposed to be on the network. And so my whole point here is that, you know, when you think of systems, having multiple buildings for a large organization, let's say a multinational global organization, this is where it becomes drastically important to have standardized naming conventions and a standardized network architecture and provisioning process to repeat the same model for every physical asset or building, and then have it managed from a portfolio standpoint or organizational wide standpoint. That's when the true transformation can happen.
Okay, I have a reaction to that, which I think, David, I agree completely with your assertion that a properly engineered network infrastructure can largely solve the challenge of what systems can see other systems and what users can then get to those systems, etc. So that works well for your Fortune 1000, if you will, your larger organizations. Right? For the 4 million other buildings that don't fall into that category, imposing the need to bring in IT qualified personnel to put in a Cisco or equivalent system, Meraki, and do the proper configuration of the subnets I still think is a fundamental challenge for our industry. And so in that case, as an example, is what BACnet is doing for device authentication. And do we need if you will, a lower tier or simpler tier solution that doesn't require so that the people, the systems who are putting these systems in don't also need to be certified in IT technologies?
I think you bring up a great point, and yes, that's absolutely the box scenario we've been talking about for a while. I think that comfortably fits into this, where that is probably like the secure router in a way for all of these different network systems. And I think of, near my house, there are lots of 9-story, 8-story office buildings that are about, I'd say, 10,000 square feet per floor or something like that, and it's the same maintenance person who's supporting 10 different buildings and probably don't have any IP experience. So it's definitely a challenge, and this is definitely I'm thinking the box solution is something that can work well for those buildings. Anything under 300,000 square feet, I think, is going to need a solution that is still IP based,
right,
but doesn't require IP support and to monitor and manage it. But this is again where, if you have a portfolio of 10 small office buildings, you probably have an IT guy in your office or who supports you, and they can monitor and manage all of those networks. This is where, no matter what the scale of the organization is, I think, looking at all of the buildings as a system instead of each building as an individual entity is where the economies of scale can come together to make this a secure thing for the smaller buildings as well.
So I'm going to tweak our format a little bit. I'm going to ask our quick fire question now, so it'll give us a few minutes to talk about it. Because we've been talking about brittleness and loosely coupled systems, and yet we've also been talking about IP. So my question is IP inherently brittle, or is it loosely coupled? So you can say brittle or loosely coupled, or you can take the fifth. I'm going to go around from the top. Ken, is the internet protocol, is the internet protocol itself brittle or loosely coupled? Your answer?
You've changed the protocol. You added
the IP, which is Internet Protocol. That's what it stands for.
You're making me change my answer. I think the protocol is brittle.
Okay. Mark? You're muted. We heard that.
I know you did. Loosely coupled.
Okay. Tracy, so it's one of each so far.
I would say loosely coupled.
Anno?
Loosely coupled.
So it's 3-1. Jim?
Brittle.
3-2. Rick?
Brittle. Tight.
3-3. Steve?
Loosely coupled.
And David?
I'm not really a binary thinker.
So you're taking the fifth?
No, I respectfully, actually, I think it's both. It depends on who's provisioning the network.
Yeah, right.
So is it closer to 0 or 10 millivolts?
Yeah. If anything, I would say loosely, though.
Okay,
I would lean towards loosely.
I would actually say brittle. And specifically, I think it's both, but I think it's brittle in the context of this conversation. The way we've been talking about IP is, I think, brittle. IP itself has enabled some amazing loosely coupled system like the internet, but that's not the same as IP, relying on IP as being the only thing that everything has to revolve around. And I specifically think that, David, what you're talking about in terms of using subnetting to differentiate the silos is the most brittle thing I've heard on this call. Because you can't, then you've created digital silos inside of this network by doing that.
Absolutely, but it's not completely secure, but it's as secure as you can make a network at the same time.
Well, what I would say is that with the technology we've worked on with BACnet SC, we're looking at a zero trust solution rather than just network segmentation. Network segmentation is good, but by actually taking each controller, each terminal device, and allowing it to have its own credentials and its own cybersecurity capability, we are getting away from segmentation or micro-segmentation, or however you want to describe it, as the only way to go forward.
Which is essentially the cybersecurity model of the internet, right?
Right.
I can go to my bank and log in because it knows it's me. It's a zero trust mechanism, unless you don't care about trust, like news sites and pizza parlors and stuff like that, and you don't have security. But that's the model of the internet, is that the IP provides a flat network on top of which you can create zero trust.
Right.
Sounds like we got the problem solved, guys.
There you go. And we
I
got
was
4
gonna
minutes
say-
to spare.
I was going to say, Anto, next time we do the rapid fire round, we should ask the audience just to post in their answers as well. It would be fun to see that just come in.
Right.
Or do it as a poll, actually.
Yeah, the thing is, we think it up in the last minute, so it's difficult to do a poll that way.
My
So-
report's planning.
Did we see, do we want to comment about to Nicholas Warren about Edge Native? GR, I saw that, and I'm actually not familiar with it, so it's not sure.
I'm not familiar with it either, but I certainly like the sound of what that is saying better than cloud native.
Keep in mind, Cloud Native Computing Foundation is a company. It's not just a concept. And
So
so
it's an existing thing.
an existing thing. And so trying to debate about whether cloud native is real is that horse has left the barn.
Yeah.
Now, what is edge native? Don't know, but cloud native is something we could actually hang our hat on and point people to a design and reference platform to work on.
And,
I was also
it
gonna
is
say-
it is at the core of how things talk in the cloud environment, right? On the internet, right? That's why cloud native is a thing of its own, is that it is the foundational way that systems talk to each other on the internet and on the cloud.
And it's sort of settled science. I mean, by the amount of adoption it's had in the different industries and by IT. I was going to say, just my 2 cents of loosely coupled versus brittle, is that it's a state of mind. For 15 years, I've been talking about being loose and shallow, and people chuckle, but it's a state of mind of how you design and how you think about systems, and whether it's at the hardware level or at the software level or at the data level. And I find that is helpful. The other thing I find helpful, and when you're thinking about loosely coupled versus brittle, is can the system, anything can be composed, but can it be decomposed, is sort of the test. And to get owners and more people to think about, okay, so I've got a system that has been nicely composed, but can I decompose it like those Connect blocks, and then use it to insert something new or get rid of pieces I no longer need.
Without breaking
anyway,
everything else.
Without breaking everything else. So those are just, thought I'd throw those in.
Yeah. Any other thoughts to wrap up? I did the quick fire too early, didn't I?
You did 2 seconds, 2 minutes too early, 1 minute too early.
Okay. So anyway, this was all obviously in the context of system of systems, and I think it goes without saying that system of systems inherently is much more nimble and loosely coupled than brittle. I mean, that's one of the ways of thinking about it, but we haven't actually sort of made that point, just made that point here to wrap up. So I think this has been a great conversation and a great way of wrapping up the System of Systems month and conversation. And we haven't figured out what we're going to be talking about next month in December. We have 3 weeks in December before we need to break for the holidays. But I think we'll wrap it up for today. And thanks everybody for being here. It's been a great conversation. So see you next week.
Thanks.
Bye-bye.
See you. Cheers.
Yeah.
you.
Bye.
Bye-bye.
Bye.